Dear students, I welcome you all to the first course in differential equations. This is our first video under the course of ordinary differential equation. So now, in this course, we will experience most of the practical applications of mathematics in real life. Real life. In this world, everything changes, changes, and as you know, for instance, in our business, sometimes you see that your profit is rising down, sometimes it's rising up and all that. Okay, so and not only that, changes happens everywhere in our real life. So how much of changes occur in these things? What is the effect of these changes on our variables? What is the effect of these changes on our variable? That is, when we bring it to mathematical terms, what is these changes in our variables? Variables like, let's say, s, y, v, u, and others. Alright, what is these changes to it? Or what does these changes mean in our real world? Most of the answers in these questions lies in differential equations. Yes, lies in differential equations. So in this course, we will be looking at one of the two classes of differential equations. That is the ordinary differential equations and the partial differential equations. We will begin with the first, looking at the background of our differential equations, solutions of differential equations, and so on. In fact, you will love it. It is imperative that you do a serious revision on differential and integral calculus, as they are the main prerequisites, or what? The RPK for this course. Alright. So since they are the prerequisite of the differential equations, you need to go back and revise on it. Again, your lesson on linear algebra and geometry will also be relevant for this course. Once again, I welcome to the first course of differential equation, and I hope you will enjoy your lesson. Alright, very good. So now, quickly, let's look at the fundamental concept and, writing words for me, okay? First ordinary differential equations. Alright. Good. So we are looking at the fundamental concept and first ordinary differential equation. So when we talk of differential equations, what does it mean? What does it mean? Now, an equation containing the derivatives of one or more unknown functions. One or more unknown functions. That is what? Or dependent variables. Dependent variables. With respect to one or more independent variables, is said to be a differential equation. For instance, all that we are saying is that if, let's say, I write y is equal to x squared plus x, or 2x, this is having a dependent variable of y and the independent variable of x. But once I try to add, let's say, v plus u, this is depending on, we have the dependent variable to be y, but it's having two or more independent variables. We have x and we also have v, and we also have u. Sometimes in change of subject, we say that make y the subject as respect to, how we can see that here. So this is something like as respect to x, v, and u. Alright, so that is what we are talking about here. So we are calling these equations for differential equations. Alright, simply a differential equation, underline it well for me. Simply a differential equation is an equation involving the unknown function y is equal to f of x, together with its derivatives. So a differential equation is an equation involving the unknown variable function y is equal to f squared, that is a function of what? Y as respect to what? X. Together with each what? Derivative, a derivative, where we can get a first order derivative in, we can get the second order derivative in, together with a y to the power n. That means that we can get 20th order differential equations and all that. Okay, so it's like when you take a derivative of a certain function one time, it is first order differential equation, like what we did in calculus 1. Okay, all right. So that is it. Now, under differential equations, we have two forms. We have implicit and what? Explicit. Implicit differential equations is when the function, the whole function is in terms of a variable s, y, y prime, and others. Okay, it continues equal to 0. When a differential equation is in this form, we are saying that it is what? Implicit. And we also have explicit form of differential equation. That is when we have the dependent variable on one side and independent variables what here. And that is what we call the explicit differential equations. Hope you understand what concept I'm giving for you now. I trust you. Alright. Now, let's look at examples of differential equations. Examples of differential equations. First one, we have y prime plus fy is equal to what? F squared. The question is, what is this a differential equation? It's a differential equation because we are having the dependent variable y innate. We also have x innate. And the most important thing is also that we are having y prime what? Innate. That is what? First derivative. First derivative. We can also have second derivative and others, but the idea is that since we have a derivative in it, then we are saying that it is a differential equation. Alright. So some for instance, you have y is equal to x plus 2x. This is not a differential equation. This is not a differential. It's just an equation, but not a differential equation. But if I take the derivative of this and I get y prime, that makes it a differential equation. Thank you. Alright. So let's look at this one. This one too. We have a differential equation. I will talk about these things. Okay. One is order and one is what? A degree. I will talk about it later. Okay, so this is a differential equation. This is a differential equation. It's a differential equation. In fact, they are all differential equations. But I want to see something here. How we write this is not the same as how we write this one. Okay, you can see y prime is the same as y ds. Okay, but you can see a sign like this in. Alright, you can see a sign like this in. Okay, so you see that with this, then it means that it is obvious that different variables and derivatives can be involved in describing what? A differential equation. Therefore, there is a need to classify these differential equations here. There is a need for us to classify this differential equation. So now let's quickly go and look at the classification of differential equations. Alright, so we know that a differential equation can be classified into two ways, and that is what? Ordinary differential equations and partial differential equations. But as far as this course is concerned, we are going to base our idea or our concept or our knowledge under only ordinary differential equations, and partial differential equation will be another thing. But we will talk about it some more for you to get the understanding or the clear idea of this partial differential equations. Alright, please make sure you write this or you jot this down. Alright, so now when we talk of ordinary differential equations, or let's say that a differential equation in the first place are classified according to the number of what? Variable what involves. We are going to classify these what? Differential equations according to the number of what? Variables what involved. And that is what we use to classify them under whether ODE or what? PD. Under whether ODE or what? PD. Alright. So when we say a differential equation, what are we actually trying to say? Please write it. If a differential equation contains only ordinary derivative of one or more unknown function with respect to a single independent variable, it is said to be ordinary differential equation. Alright, let's write. Okay, so we are saying that we are going to classify in the first place according to the number of variables in it. So what we are saying is that we have two classifications. Classification of differential equation. And the first one is what? ODE. ODE, that is ordinary differential equation. And the second one is DD, and that is partial differential equation. Alright, so when we talk of the ODE, if a differential hope you are right. If a differential equation contains only one or more unknown function with respect to a single independent variable. It is said to be ordinary differential equations. Wow! Good! The key word here to underline is single independent. Independent. So if it's involving with only one single variable, let's say we have a derivative of y as respect to s. This means that it is a differential equation or a derivative of y as respect to v or u. That means that it is containing of only one single independent variable. So we can classify such differential equations under ordinary differential equations. Very good. So you can see some of the examples here, and I will give you more examples as we go on, and you will love it. All right. Now, what about PD? In fact, you can iterate this idea with PD on 2. All right. So now, let's look at the second classification, and that is PDE. Very good. And there is a course on its own. Yeah, it's a course on its own, and I love it. An equation involving partial derivative. An equation involving partial derivative of one or one or more unknown functions of two or more independent variable is called partial differential equations. Alright, so that is that for PD. We are saying that an equation involving partial derivatives of one or more unknown functions of two or more independent variables is called partial differential equation. Alright, let me explain something more. We are saying that one thing you take note here is that we are saying that here ODE contains only one or more unknown, but here PD contains one or more unknown functions. You see, it's the same here, right? Containing only one or more unknown function with respect to single independent. With respect to single independent. But here, this one contains one or more unknown function of two or more independent variables. So the concept here, or the idea here, is about the independent variable. One is single and one is two or more. That means that one is single and one is multiple. Alright. So looking, and we are also saying that it contains partial derivatives. So as I said, this is a partial derivatives and this is just ordinary derivatives. Alright, so looking at these examples here of differential equation, we can say that this one is ordinary differential equation, ordinary differential equation, ordinary differential equation, and the reason is that we are not having a partial derivative in it. Secondly, it's also that it is involved with only one independent variable. There is no case that you see we have the dependent variable here to be y, but we also have the independent variable here to be x. There is no case that you can say, let's say, plus u or something like that. No, it's not of such case. So the first three here is ordinary differential equations, and from 4 to 6 is partial differential equation. Alright, so that is what PD. Thank you for that, and I hope you have understood it. Alright, we have order of differential equation, and that is what we are going to look at it right now. Order of differential equations. Order of differential equations. Then we look at linearity of differential equation. There are some equations that are linear and some equations that are not linear. We are going to look at these ones also. Alright, so make sure you make a good note and just I'll be back again. Alright, welcome back. Let's continue. Okay, so now we are looking at order of differential equations. Let's first look at the order of differential equation. Now, when we talk of order, we mean that the way something is arranged or something like that. I hope it's clear. Alright, so in general, differential equations of in general, differential equations of order n can be written as a subscript n. This is a subscript n. S and that. So this is what the general. So the n here is the order. Then the order reduced by 1. Then it goes like that. Okay. Alright. So that is the differential equation of order in general form. Okay. So where the coefficient of now the a0, a1, you can also have a2 and other. So a of n and the f of s, that's the capital F of s, continuous functions on and what? Interval. They are specified as what? A continuous function of. All that we are saying is that, for instance, for this and this to be 0, the order will cease to be what? Exist. Okay, so that is that. Let's look at linearity of differential equation. Linearity of differential equation. A differential equation can be linear or non-linear. So, first of all, you know that a linear equation, differential equation can be linear or what? Non-what? Linear. Very good. The ordinary differential equation can be linear if these three conditions what? Exist. Here, we are going to deal about important matters here. I'll combine the order and the whether linear or non-linear example for us to discuss. But for now, for ODE can be linear if these three conditions are what? Met. The first one is the dependent variable and its derivative occur to the first degree only. When the dependent variable and its derivative occur to the first degree only, then we say that it is a linear differential equation. No product of y or any of its derivatives are present. No product of what? Y. No product of y like y. No product of what? Y. That means that y squared can be linear, y to 3. If y to 3 or y to 2 is among the differential equation, it seems to be what? A linear differential equation. It seems to be a linear differential equation. Let me explain this one too well for you. The dependent variable, that is the y, and its derivative occur to the first degree what? Only. It occurs to the first degree only. That means that the dependent variable like y is derivative and its what? Derivative occur to the first degree what? Only. We will talk about that when we deal with the examples. 3. No transcendental function of y and or its derivative occur. Now, the key word here is the transcendental function. When we talk of the transcendental function, what are they? Natural log is a transcendental function. Natural log is a transcendental function. Cos, in fact, all the trigonometric functions, sine, cos, tan, they are all what? Transcendental functions. So we are saying that no transcendental function of y, that means that if you have, let's say, sine y, be among of the differential equation, it seems to be a linear differential equation, or e to the power y. This, if you have such in the differential equation, it seems to be a linear differential equation. Alright, whether prime or whatever. That's why it's saying that no transcendental function of y and its derivative. So if you have even cos y prime, it seems to be a linear differential equation. So, and if it's not linear, it is what? Non-linear. So, in case one condition is met, it's non-linear. Okay? And in case, in fact, the thing seems to be a linear differential equation if you don't see at least one or two of these what? Measures in the differential equations. Let's look at some of the examples where we are going to explain to you well about the order and the linearity of differential equations. Alright, now let's look at something I forgot to tell you. For instance, if you have y is equal to 2x plus x squared, and I ask you to differentiate this. This is dy dx is equal to what? And we have 2 plus 2x. Alright. Now, dy a differential equation of order what? 1. Because you can write this dx as y prime is equal to 2 plus 2 of s. We can also rewrite this as y prime minus 2s is equal to what? 2. So this is of order what? This is of order what? 1. But if I differentiate these results again, let's say if I differentiate y, I get y prime prime. Minus if I differentiate this, I get 2 is equal to what? 0. This is a second what? Derivative. So the order of this differential equation or this ordinary differential equation is of order what? 2 because of its second what? Or because it is in the second derivative what? Form. Now, no matter what this is, okay, in case I have y prime prime plus 2y prime plus 3s equal to 0. This is still a second derivative of order what? 2. Of order what? 2. Whether it's linear or non-linear, I'm going to explain it well under this what? Example. Alright. So this is what I want to first take you through. And also, in case that if I want the third derivative, I will represent it by y prime prime or dy dx keep. Then here we keep. I hope you can see that. Alright, but normally we represent it as this. But if I want to differentiate it 4 times, if I want the fourth order, I can't write y prime 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 prime. No. What we represent fourth order with is breaking it in a closed bracket like this. So if I want the fifth order, I'll make it like this. The 20th order, I'll make it what? Like this. Please, this is different from a degree. Get me what? This idea is different from what? A degree. This doesn't mean it's a degree. It's very, very important for you to take note of. This doesn't mean that it is what? A degree. But if I write y prime prime all square, this is a second derivative or order 2 of degree 2. Second derivative of order 2, degree 5. Very good. I heard you saying it, yes. Alright, what if I do something like 4? This is order 4 of degree what? 5. Very good. So that is how we represent the degree. Or d square y over dx square all to the power 3. This is a second order of degree what? 3. So degrees is not the same as what? The order. Alright. Coming back to these questions. For each of the differential equations, state whether it is linear or non-linear. Whether it is linear or what? Non-linear. And give it order. And give it what? Order. That is what we have just what? Explained. Alright. So looking at the A. Looking at the A, we have y prime prime plus 3y prime plus y is equal to what? Z. So looking at the differential equation in the A, we can see that we have the second derivative in it. In fact, it is an ordinary differential equation. Alright, so you don't think of PD because whatever we are doing is ODE. Alright. So this is second order derivative, first order derivative, and this of a function that is a dependent variable. Alright. So when I ask you of the order, you have to check the higher derivative, and here the higher derivative is what? 2. So this A is of order what? 2. Then let's talk about the linearity. Is this linear or non-linear? Wow! Then you go back to your it's like a law, okay? It's like a law. One cannot be broken. Alright. So let's see if all these conditions are met. The ODE can be linear if the dependent variable and its derivative occur to the first degree only. Do you know what this means? Now I'm going to explain to you. For instance, if we have y prime and degree 2, this cannot be a first order linear differential equation. This cannot be linear. And if we have even third order and we have a degree of 3 or a degree of 5, these two fail to be what? A first order linear differential equation. So this is not linear. So looking at the first condition, we can see that such is not here. So then the first condition is met. No product of y and or any of its derivatives are present. No product of y and any of its derivatives like y prime prime. No, we don't have such in it. We don't have such in it. And since or y squared, we don't have such in it. And since we don't have such in it, we can say that the second condition is also what? Met. Very good. Looking at the third one. No transcendental function. Oh, there's nothing like sine, cosine, or the trigonometric functions and natural logarithms. It's in it. So we stop even think of it whether it is in terms of s or the derivative. So it's also linear. So it's also what? Linear. P. Straight away. Hope you can see that. There should be no product of y. But here we have a product of y here. So straight away, this is non-linear. This is what? Non-linear differential equation. This is non-linear. Sorry, I'm coming. Okay, this is non-linear. This is non-linear because of the product of y. Because we have y and y, that's why we have no y squared. Alright, this is the product of s and y. Yeah, I have no problem. But because of this, it's failed to be a linear. Alright. Order. Oh, we have only one order. Because with s squared plus y squared ds is equal to 2sy dy. Okay, we can divide s squared minus y squared over this 2sy. Okay, 2sy to be equal to here will be left with what? Dy. We have divided this by this. Okay, and here is what? Dy. And divide both sides by this ds, and we get here to be what? Ds. Please don't be confused. So we have something like this is the same as y prime. So this is just a first order differential equation. So it's order 1. It's order 1. Very good. C. No transcendental function. So don't even think of these things. Don't even think of the third one. No product of y's. No product of y's. And there's something like y prime to the power 2. There is no degree like that. And that's the first condition. And no product. Oh, then this is first order. This is first order. It's this is linear. This is linear. And the order is, oh, thank you. I heard you say the order is 3. D. The order is 3. Oh, as I said, this is not a degree, but it's of what? Order 4. Very good. Order 4. F of x. Don't be confused with F of x. This is a function of what? S's. Okay. So this can represent by something like either s squared plus 2s or something like that. So there is no problem in it. It's It's linear. It's linear. It's linear. It's linear. E. There is product of y. There is product of y. Since there is product of y, this failed to be linear. So this is what? Non-linear. And also it is of order 1. Order 1. F. Very good. We can also see something here. I hope you can see that. Alright. They say you fail to be linear. Non-linear. Non-linear because of this. Non-linear. Because of this, you are non-linear. Because of this, you are non-linear. That's it. What again? Right. Order. The order is 1. Order of 1. I hope you understand it now. Okay. Let me see if I can get more of the examples to add up. Good. You can pause the video and write it. Let's look at this. E, F, G, G, G. G, example G. Let's design S, Y prime prime plus ln S, Y prime plus e to the power x, y. Very good. Let's look at something also like from G, we go to H. F, G, H, okay, H. So let's see. Y prime 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 plus 4y prime is equal to e to the power y. Very good. Let's look at this last two. This last two. Oh, first of all, order, and the order is simply 2. Order 2. Is it linear? There's a transcendental function in it, but I say there are no transcendental function of y. First of all, there is no transcendental function. This is a transcendental function of s. Transcendental function of x. Transcendental function of x. Oh, but you see, the y here doesn't mean this is a transcendental function of y, okay? Because this is just a product. It's just a product of this. And of course, and the condition didn't say that no transcendental function and a product of what? Y. It's not like that. So this is a transcendental function of x multiplying y. So this condition is met. No product of y. There is no product of y and its derivative. There is nothing like y power 4y. No, there is nothing like that. The dependent variable and its derivative occur to the first degree only. No, there is nothing like that. So if it occurs to the first degree only, that means that let's say y prime prime, then it's occurring to the first degree or 1, not 2, 3, 4, 5. I keep explaining these things. It's very important. So that is what it means. So this is linear, purely linear. H. Transcendental function of y. So non-linear. Straight away, non-linear. Don't think of whether two conditions is meeting here. Just forget. It is non-linear. And lastly, order 3. Order 3. Order 3. That is that. Alright? So, thank you. Hope you understand it. I forgot to give you a trial for you to try your hands on it. Alright? So, this is your trial. Fast, start. And when you are done, you know my contacts. Hope you know it. Alright? That is 055 78 59 597. For the purpose of those who is not in Ghana here, is +233. Alright, +233. This Ghana number. Alright, very good. So that is it. In case of any challenge, you can WhatsApp me or send it to me through an email. Alright, that is Frederick, Frederick at 88gmail.com. Alright, so that is that. Thank you. See you for another day. And our next meeting, we are going to look at the formation and the definition of differential equations, and you will have it. Alright, not only that, we will also be looking at a lot of stuff. Okay, you should be able to verify whether a given function is a solution to a partial differential equation or what, not, and others. Okay, see you for that. Alright, let's combine it with formation of differential equation in this video. Now, when we are going to form differential equation, it's just simple. Any equation which is in terms of whether first derivative, second derivative, third derivative is what? A differential equation. So it's just simple. So let's look at this question. Use the function y is equal to cos x. Right, use the function y is equal to cos x to form a differential equation. All we are saying is that take y is equal to what? Cos x to form a differential equation. Now, it depends on individual sake, okay? You can get different kinds of differential equations from this function. You know why I'm saying that? Let's see. Take the derivative of this, you get y prime or dy dx, alright? To be equal to when you take the derivative of cos x, you get what? Negative sine s. Very good. Now, with these results, someone can choose to write this y prime plus sine s is equal to 0. Now, the differential equation is formed. This is a differential equation. This is also what? A differential equation. Alright? We can write it in so many ways. Now, let's look at it in the second derivative. Let's go for it in the second derivative. From y prime is equal to negative sine s. What can we get here? Second derivative, we get y prime is equal to what? When you take the derivative of this, what will you get? When you take the derivative of this, you get negative cos what? X. Very good. But you see, this is a differential equation. This is also a differential equation. Alright? And this is a differential equation of order 1. This is a differential equation of what? Order what? 2. But looking at what we have here, we know from the question that y is equal to what? Cos s. And if we have y to be equal to cos s from the question, by substitution, somebody too can leave his differential equation in second order in the form y prime is equal to what? Negative y. Equation 3. This is also a differential equation and it's correct. So you cannot say that this is wrong and this is correct. It's based on what? Individual concept. Alright? And even this can be written also as y prime plus y is equal to what? 0. It's also a differential equation. Marvelous. So that's how you form a differential equation. You see, you love it. You see, it's very simple, okay? You are loving it, I can see that. Alright, so let's look at something like, we can also get something like, let's see, y of s is equal to tan s. To differentiate this, you get y prime is equal to what? Differentiate tan, you get z square s. You get z square s, right? Okay, look at something here. So for first order, we get this. But somebody can also choose to say that, but z square s is equal to what? 1 plus tan s. And for that matter, y prime is equal to 1 plus tan s. It's also a differential equation, just that it's not the same thing, but it is in the same form. You can't say this is correct and this is wrong. It's still the same thing. Alright? And even someone too can still continue to manipulate x to say that, but y is equal to what? Tan s. And since y is equal to tan s, you can leave his differential equation in the form y prime is equal to 1 plus y. How we can see that? So we can get a lot of differential equations based on the concept of each individual. And we can also get second order differential equation to be y prime prime is equal to this is 0, so we get y prime. And somebody too can choose to write it y prime prime minus y prime is equal to 0. Beautiful. You see how it is? I'm sure you can, or you are also coming out with a lot of stems. Oh, sorry, here is tan square. And, okay. So, I should have rather said that, but y is equal to this, therefore here will be what? Square. Alright, okay. So, okay, that's it. Because you do the substitution, you get the y squared. So if you want to go by second derivative, this will be 0. By here you get 2y, very good. Interesting. Here you get 2y dy dx, because it is an what? Implicit. It is an what? Implicit. So you get what? 2y dy dx, because you are taking the derivative and respect to what? X, not y. So it's an implicit. And somebody too can choose to rewrite this as y prime prime is equal to 2y prime, which is the same as y prime prime minus 2y prime is equal to 0. So I hope you understand it. In case you don't understand it, you play back, and play back again. Alright. So I would like you to go and try your hands on this. Form a differential equation under y in terms of s squared plus 1 to the power of 5. Okay. So use this to form a differential equation. And Charlie, you need a calculus, because you don't know that this is a chain rule or a general power rule. How will you go about it? So in this case, you get dy dx is equal to 5 s squared plus 1. Then subtract 1 from it, you get 4. Take the derivative of the inside, you get 2x. Alright, then like that, I'll continue with it. And you can get about 3 or 2 from this function. Alright, thank you and see you for another video.